Hello, students. In this lesson, we will learn about Logistics Decision Support System. Main contents include the definition of Decision Support System, the classification of Decision Support Systems, and the application of Decision Support System in logistics. Definition of Decision Support System. Decision Support System (DSS) is an evolving concept. In the 1970 S. Scott Morton's definition, an interactive computer system that helps decision-makers use its data and models to solve unstructured problems. In the mid-1980 S. R. H. Sprague proposed. The characteristics of DSS, one, data and models are the main resources of DSS. 2, DSS is used to support users to make decisions, rather than replace them. 3, DSS is mainly used to solve semi-structured and unstructured problems. 4, the purpose of DSS is to improve the effectiveness of decision-making, rather than the efficiency of decision-making. In the 1990 S. Toubon proposed that DSS is a tool to enhance decision-making ability of decision-makers. Comparison between DSS and MENS is shown in the following table. Question: what is the difference between DSS and MIS? As shown in the following table. Classification of Decision Support Systems. Classification according to system characteristics: ATA-oriented DSS, model-oriented DSS, classification by purpose of use, special DSS, generic DSS, generators, development tools. Classification according to use form, institutionalized DSS. Repetitive, similar decision problems, dynamic DSS. Application of Decision Support System in logistics. Demand plan. Logistics network design. Inventory configuration. Division of sales and marketing area. DRP. MRP. Inventory management. Production site location. Vehicles plan. Lead time quotation. Production plan. Scheduling optimization technology of logistics transportation system. 1. Demand plan. Making accurate demand forecast. 2. Is the key to improving the efficiency of the whole supply chain. Therefore, forecasting has become an important area of DSS. In order to assist this process, in addition to typical statistical tools, collaborative tools and standards have been developed. Example: the American Red Cross used a decision support system based on optimization models to evaluate recommendations for reselection of blood distribution and collection sites. 2. Logistics network design. The design of logistics network includes the determination of warehouse and factory locations, the configuration of retailers and customers around the warehouse, etc. Usually, the input data include alternative locations, transportation costs, total demand forecast, etc. When proposing logistics network design schemes, heuristic and optimization algorithms are often used. For criteria that cannot be quantified, decision-makers ultimately need to rely on their own judgment. Example: in 1993, Procter & Gamble PG began to redesign its entire supply chain plan. Through mathematical tools in the DSS system and GIS system, they reduced the number of distribution centers and retained well-located distribution centers. Question: what role can GIS technology play in the decision support system of PG Company? 3. Inventory allocation. Enterprises need to make decisions on which warehouse to keep what kind of inventory at what time, which is the inventory allocation decision. In inventory allocation, transportation costs,
demand forecasts, and existing inventory
are used to determine the level of inventory to be maintained at each location at each time. Moreover, DSS again uses optimization and heuristic algorithms to generate recommended strategies. Example: Amoco. Once faced the following common inventory management challenges. 1. How to identify appropriate inventory levels at different links of the supply chain. 2. How to overcome the capacity constraints of capital, equipment, and personnel. 3. Conflicting organizational goals among sales, production, and inventory management personnel. To address these issues, Amoco, together with Merck Management Consulting, developed a decision support system suitable for itself. This system can simulate Amoco's logistics network, costs and objectives at all levels, and in the analysis process, uses optimization and simulation techniques. The system brings the following benefits. 1. Clarifying inventory costs,
including out-of-stock costs.
2. Overstocking cannot cover up inefficient work. 3. Better planning, coordination and communication, in sales and marketing area division. 4. Division of sales and marketing areas. The division of sales areas needs to maximize sales and keep both customers and sales representatives satisfied. The decision support system for sales area division takes customer locations and demand forecasts as input, and the design of sales areas should be based on a series of goals selected by decision makers, such as distance and sales potential. 5. Distribution resource planning DRP. For a group of warehouses and retailers, this model is used to determine appropriate distribution routes and inventory policies. Given the locations of warehouses and retailers, inventory and transportation costs, and demand forecasts for each retail point, this system can use analytical tools to determine strategies for providing customers with high-level service at the lowest cost. 6. Material requirements planning MRP. MRP systems use product bills of materials and component lead times to plan when to start manufacturing a product. Although these decision support systems do not use complex mathematical methods, they are very widely used in industry. Bill of materials. Example: Tanner Company, a manufacturer of high-quality women's apparel. In the early 1990s, the company's on-time delivery rate was low, around 74%, and there was a large amount of work in process. Company's DSS records detailed information on materials and labor requirements for each style produced by Tanner in a database. The system extracts data from this database based on the data in the database and the orders received.
It generates a production plan.
Especially under production and demand constraints, the plan made by the system aims to minimize both shortages and finished goods inventory. Operation results. At the end of 1 year, the system was developed, modified, installed, and implemented. On-time delivery rate increased to 90%, and work-in-process inventory was reduced by more than $200,000. 7. Inventory management. An inventory management decision support system can use transportation and holding cost information, as well as production lead times and item demands, to formulate inventory policies, thereby helping decision-makers achieve the goals of reducing costs and improving customer service quality. 8. Production site selection facility layout. Each point in the production facility network produces different products or different components of the same product. Facility layout decision support system takes production costs, lead times, transportation costs, and demand forecasts as input data, and assigns different products or components to production facilities. Example: Mobil used a DSS to consolidate and ship lubricant products. To solve a series of problems for dispatchers, deliveries such as own vehicles or external vehicles, order consolidation strategies, etc. Internally, The DSS used the Heavy Product Computer-Assisted Distribution HPC system developed by Mobile in collaboration with Insight to formulate cargo delivery plans. The HPC system saves the company more than $1 million annually. 9. Vehicle planning. Vehicle planning includes not only the dispatch of enterprise-owned vehicles, but also the selection of commercial vehicles on certain routes. An important part of vehicle planning is vehicle routing. Example: CSX Transportation, which owns one of the longest railways in the world, developed a decision support system called computer-assisted routing and scheduling cars, which is used to explore the strategic relationship between routing and scheduling. CSX Transportation Company Profile. 10. Lead time quotation. Lead time quotation decision support system can quote the exact delivery lead time for a specific order, and this lead time is often short. Question: under what circumstances should the lead time be quoted as long as possible? 11. Production plan. Given the product series to be produced, the production process, and the due dates of products, the production planning DSS can determine the production sequence and schedule. Production planning DSS can use artificial intelligence, mathematical and simulation techniques to develop production plans. 12. Scheduling optimization technology of logistics transportation system. The scheduling optimization of logistics transportation system includes the scheduling optimization technologies for collection of distribution vehicles, cargo loading and delivery process, among other key technologies. Heuristic algorithm, genetic algorithm, and algorithm. This lesson ends here. Thank you.